Welcome. Today we will see bevel gears. This is the image of bevel gear. Contents: introduction, classification of bevel gears, terminology used in bevel gears, force analysis, beam strength of bevel gears, wear strength of bevel gears, effective load on gear tooth. Now we will see introduction. Bevel gears are cut on conical blanks whose pitch surfaces are frustum of cones. The bevel gears are used for transmitting power at a constant velocity ratio between two shafts whose axes intersect at a certain angle. The elements of the cones intersect at the point of intersection of the axis of rotation. Since the radii of both the gears are proportional to their distance from the apex of the cones, therefore the cones may roll together without sliding. This is the main advantage of bevel gears over other type of gears. Classification of bevel gears. The bevel gears may be classified in two ways as follows: based on profile of tooth and based on angle between the axes. Now we will see classification based on profile of tooth. The various types of bevel gears used based on tooth profile are as follows. First, straight tooth bevel gears. Now you just see this is the image of the straight tooth bevel gears. The tooth or the teeth on the gear are straight. Straight tooth bevel gears. The elements of the teeth of the straight bevel gears are straight lines which converge into a common apex point. That is this common apex point. Straight bevel gears are easy to design and manufacture and give reasonably good service when properly mounted on shafts. However, they create noise at high speed conditions. Spiral tooth bevel gears. The elements of the teeth of the spiral bevel gears are spiral curves which also converge into a common apex point. Involute profile is used for the form of the teeth of gears. Spiral bevel gears, on the other hand, are difficult to design and costly to manufacture, for they require specialized and sophisticated machinery for their manufacture. Spiral bevel gears have smooth teeth engagement which results in quiet operation even at high speeds. They have better strength and are thus used for high speed, high power transmission. This is the image of the spiral bevel gear. Teeth are of spiral shape. Zero tooth bevel gears. Zero gears are spiral bevel gears with zero spiral angle. These gears theoretically give more gradual contact and a slightly larger contact ratio. This is the image of zero tooth bevel gears. Face bevel gears. Face gears consist of a spur or helical pinion mating with a conjugate gear of disc form. They are shown in figure. Face gears have the following characteristics. First, the pinion of face gears is either a spur gear or a helical gear. Second, face gears are mounted on intersecting shafts that are at right angles to each other. The teeth of face gears can be straight or curved. Face gears have the following advantages. First, they can be cut with spur gear cutters and gear shapers. Second, the axial position of the pinion is not critical as in case of bevel pinion. The disadvantage is that the width of the tooth face is small. Skew bevel gears. When two straight bevel gears are mounted on shafts which are non-parallel and non-intersecting, they are called skew bevel gears. They are shown in figure. It is seen that the apex point of pinion is offset with respect to that of gear. Skew bevel gears have the following characteristics. First, skew bevel gears have straight teeth. Second, skew bevel gears are mounted on non-parallel and non-intersecting shafts. This is the diagram of skew bevel gears. Hypoid bevel gears. Hypoid gears are similar to spiral bevel gears that are mounted on shafts which are non-parallel and non-intersecting. They are shown in figure. Hypoid gears are based upon pitch surfaces which are hyperboloids of revolution. When two hyperboloids are rotated together, the resultant motion is a combination of rolling and sliding. The sliding is along the length of teeth and results in increased friction. On this account, extreme pressure lubricants are used for these gears. Sliding friction reduces the efficiency of hypoid gears. The efficiency of bevel gear drive is 98 to 99%, whereas that of hypoid gears is 96 to 98%. Hypoid gears have the following characteristics. Hypoid gears have curved teeth. Second, hypoid gears are mounted on non-parallel and non-intersecting shafts. Hypoid bevel gears are mainly used in automobile differentials. These gears allow the drive shaft to be placed well below the center line of the rear axle and thereby lower the center of gravity of the vehicle. Another advantage of hypoid gears is that the offset of the shaft is so great that the shafts may continue past each other. Therefore, multiple power takeoffs from a single shaft with several pinions is possible. Hypoid gears give noiseless operation even at high speeds. Now, next classification, that is based on angle between the axes. The various types of bevel gears based on angle between the axes are: first, external bevel gear. The angle between the axes of these bevel gears is 0 degree as shown in figure. The contact between the teeth of these gears is external. Acute angle bevel gears. The angle between the axes of these gears is less than 90 degree as shown in figure. This is the angle theta, it is less than 90 degree. Third, right angle bevel gears. The angle between the axes of these gears is 90 degree as shown in figure. This is the axis of this gear, this is the horizontal axis. The angle between the axes is 90 degree. Miter gears. When two identical bevel gears are mounted on shafts which are intersecting at right angles, they are called miter gears. They are shown in figure. This is the diagram of miter gear. The angle between the shafts is 90 degree and these two equal bevel gears are there. Miter gears have the following characteristics. The pitch angles of pinion and gear of miter gears are same and each is equal to 45 degree. The pinion and gear of miter gears rotate at the same speed. The pinion and gear have same dimensions, namely addendum, dedendum, pitch circle diameter, number of teeth and model. The pinion and gear of miter gears are always mounted on shafts which are perpendicular to each other. Obtuse angle bevel gears. The angle between the axes of these gears is more than 90 degree as shown in the figure. See that the angle is more than 90 degree, that is theta is greater than 90 degree. Crown gears. In a pair of bevel gears, when one of the gears has a pitch angle of 90 degree, then that gear is called crown gear. Such bevel gears are mounted on shafts which are intersecting at an angle that is more than 90 degree. The crown gear is equivalent to the rack in spur gearing. The pitch cone of the crown gear becomes plane. They are shown in figure. Crown gear arrangement has the following characteristics. First, the pitch angle of crown gear is 90 degree. See that this is the crown gear, its angle is 90 degree. The bevel pinion and crown gear are always mounted on shafts which are intersecting at angle more than 90 degree. See that this is bevel pinion, angle is more than 90 degree, that is 90 plus gamma. Internal bevel gears. When the teeth of bevel gear are cut on the inside of the pitch cone, it is called internal bevel gear. In this case, the pitch angle of internal gear is more than 90 degree and the apex point is on the back side of the teeth on that gear. They are shown in figure. Internal bevel gears are used in planetary gear trains. In case of internal bevel gears, theta is equal to 180 degree. Now we will see bevel gear terminology. These two figures are there. Different terms used in bevel gears, that is, this is the back cone, this is the pitch cone, this is same center line, middle center line is known as pitch line, angle with respect to horizontal of pitch line is known as pitch angle. This is the face angle, O means this converging point. This is addendum angle, this is dedendum angle, this is the root angle. This A naught is nothing but cone distance, HA is nothing but addendum, HF dedendum, RB, this is nothing but pitch circle radius, D is the diameter at the large end side of the bevel gear, large end tooth side of the bevel gear. Now we will see different definitions. Pitch cone. Pitch cone is an imaginary cone, the surface of which contains the pitch lines of all teeth in the bevel gear. Cone center. The apex of the pitch cone is called the cone center. It is denoted by O. Cone distance. Cone distance is the length of the pitch cone element. It is also called pitch cone radius. It is denoted by A naught. Pitch angle. The angle that the pitch line makes with the axis of the gear is called the pitch angle. It is denoted by letter gamma. The pitch angle is also called center angle. Addendum angle. It is the angle subtended by the addendum at the cone center. It is denoted by alpha. Dedendum angle. It is the angle subtended by the dedendum at the cone center. It is denoted by delta. Face angle. It is the angle subtended by the face of the tooth at the cone center. Face angle is equal to pitch angle plus addendum angle, that is gamma plus alpha. Root angle. It is the angle subtended by the root of the tooth at the cone center. Root angle is equal to pitch angle minus dedendum angle, that is gamma minus delta. Back cone. The back cone is an imaginary cone and its elements are perpendicular to the elements of the pitch cone. Back cone distance. It is the length of the back cone element. It is also called back cone radius. It is noted by letter RB.